Welcome back to Max with RP. Today we are going to do simple problems based on the concept of tangents to a circle. We've already done a few set of problems based on the same topic. Today again we will try to recall the concept of tangent to a circle and how to resolve certain problems. So this is the first problem. You have two circles touching each other externally at the point P. AB is a common tangent to the circles touching them at A and B. You have to find the value of angle APB. So what you need to find is angle APB. So to find angle APB. So what do you observe? Okay. Now, from the point C, CA and CP are tangents to the first circle. We know that the tangents drawn from an external point to a circle are equal in length. Okay. So, what are the observations that you are making? Observations. So, CA equal to CP. Why? Tangents drawn from an external point to a circle are equal. From an external point to a circle are equal. Okay. Now, if two in this triangle, if two sides are equal, you know the angles opposite to them will be equal. So, you get this implies angles opposite to them are equal. CA angle opposite is angle 2. This is angle 1. So, angles opposite to equal sides. In a triangle are equal. Okay, now we have angle 1 equal to angle 2. By similar argument, this is we have considered from point C, the tangents drawn to the first circle. Now look at the second circle. Now CB equal to CP. CB equal to CP. Why? Tangents from an external point to second circle. This is first circle. So tangents drawn from an external point to second circle are equal. Okay. Now again in this triangle CBP, if two sides are equal, angles opposite to them will be equal. So which implies angle 3 equal to angle 4. Angles opposite to equal sides. Okay, so this is what observations we have made. Now what is it we need to do? We have to find the value of angle APB. What is angle APB? That is angle 2 plus angle 3. Now what do we know? Angle 1 plus angle 2 plus angle 3 plus angle 4. If I add all these angles, they form the angles of the triangle APB. So in triangle APB, this is equal to 180 degrees. But angle 1 is equal to angle 2. So these two I can write it as twice angle 2. And angle 3 equal to angle 4. So these two I can write it as twice angle 3. This is 180, which implies angle 2 plus angle 3 is 90. What is angle 2 plus angle 3? That is angle APB. So we have found the angle APB to be 90 degrees. So what is the property of the, tangents that we are using here? The length of the tangents drawn from an external point to a circle are equal. That we are using. And angles, if two angles of a triangle are equal, the sides opposite to them are equal. And the sum of the angles in a triangle is 180. So these are the properties of triangles and tangents that we are using in order to find the value of angle APB. Is it clear? Now, a circle is inscribed in a triangle ABC. So you have ABC and you have a circle which is inscribed in the triangle. That means it is touching the sides of the triangle. At what points? D, E, F. Now you are also given BC is 8. BC is 8. Okay. And AC is 10. And AB is 12. Okay. You have to find AD, BE and CF. Okay. You have to find the values of. So to find AD, BE and CF. What is given? These three lengths are given. Okay. Now, again, I am going to use the important property of tangents, that the length of the tangents drawn from an external point to a circle are equal. So, if you let AD be X, then what do you observe? This will also be X. AD is equal to AF. Let therefore, if AD is X, then AF is also X. Okay. Now, we know the length of AB. What is the length of AB? 12. So, if this is X, this will be 12 minus X. If this is 12 minus X, then BE will also be 12 minus X. This implies BD equal to 12 minus X, which is also equal to BE. Why they are both equal? Again, tangents drawn from B to the circle are equal in length. Okay. Now, what is the length of AC? 10. So, CF will be 10 minus X. Now, CF is equal to CE and both will be equal to 10 minus X. So, this is also 10 minus X. Okay. So, for us, it is like a game where we have to unscramble the given information and determine the value of X. So, we know that BC equal to 8. Okay, BC equal to 8 centimeter. Now, what is BC? BE plus CE. So, BE plus CE equal to 8 centimeter. Now, what is BE? BE is 12 minus X. So, 12 minus X plus what is CE? 10 minus X equal to 8. Okay. So, 22 minus 2X equal to 8. So, 2X equal to how much? 22 minus 8. Which is 14. So, X is equal to 7 centimeter. If X is 7, then what do you get? AD will be equal to, this means AD equal to 7 centimeter. What else do you need to find? BE. What is BE? BE is 12 minus X. So, 12 minus 7, which is 5 centimeter. Then what else do you need to find? CF. What is CF? CF is 10 minus X. 10 minus 7, which is 3 centimeters. So we have now found the values of AD, BE and CF using the given information. Is it clear? Now in this figure, ABC is a right-angled triangle. That means angle A is 90. Therefore, it's a right-angled triangle. Angle A is 90 degrees. Okay. And you're also given AB is 6. AC is 8. A circle with center O has been inscribed inside the triangle. You have to find the diameter of the inscribed circle. Okay. So if you know the radius of the inscribed circle, that means the diameter is also known. So let R be the radius of the inscribed circle. So let R be the radius of the inscribed circle. If R is the radius of the inscribed circle, that means this is R, and this is R. Okay. Now radius is perpendicular to the tangent. Okay. Now this angle is 90 degrees. So this is also 90. So this is also 90. So the fourth angle will also be 90. Now these two are radii. So the adjacent sides are equal. Therefore, what is the conclusion that you draw? This is, let me call this point as B and this as C. ABOC is a square. And what is the side of the square? Of side R centimeter. Okay. So what do you observe? This is 90, this is 90. Therefore, all the four angles, this is also radius. Radius is always perpendicular to the tangent. All the four angles are 90. Adjacent sides are equal. Therefore, it forms a square of side R centimeter. Okay. Now, this is also R. So, what will be? Already there is B here. So, I will change it to I'll change the names. So let me, ABC has already been used. So let me use D and E. Let this be D and this be E. This is O. So therefore, A, D, O, E is a square of side R centimeter. A, D, O, E is a square of side R centimeter. Okay. Now, this is R. So, what the length of AB is 6. So, this is 6 minus R. Okay. So, BD equal to 6 minus R. Now, this is 8 and this is again R. So, this is will be 8 minus R. So, CE equal to 8 minus R. That means this point, let me take it as M, CM will also be 8 minus R. CM will also be 8 minus R. Tangents drawn from an external point C. Similarly, from B, these two are tangent segments. Therefore, BD is 6 minus R implies BM is also 6 minus R. Now, what is it that we have? Therefore, BC equal to, now this is also 6 minus R. On one hand, it is 6 minus R plus 8 minus R. 14 minus 2R. Now, this is a right angle triangle. If this is 6 and this is 8, what will be BC? Triangle ABC is a right triangle. So, Pythagoras theorem can be used. Right? So, BC square is equal to AB square plus AC square. What is AB square? 36. What is AC square? AC is 864. So which is 100. So BC is 10. So this is 10. So 2R equal to 14 minus 10, which is 4, or R equal to 2 centimeter. Therefore diameter will be 2R, which is 4 centimeter. So we are only again repeatedly using one concept, how we can solve different types of problems. That's what we are seeing. What is the concept that we are using? The tangent segments drawn from an external point to a circle are equal. We have also used Pythagoras theorem here, and the radius is perpendicular to the tangent. Now look at the next problem. A quadrilateral ABCD circumscribes a circle. That means what? The circle is drawn inside the quadrilateral in such a way it touches the sides at one point. Okay. So what do you observe here? Again, I'm going to make use of the same result, that the tangents drawn from, for example, the point A to the circle are equal. So AP equal to AS, right? BP equal to BQ. DS is equal to DR. CR equal to CQ. Tangents drawn from an external point to a circle. Are equal. Now what is it you have to prove? You have to prove AB plus CD is AD plus BC. So we have to look at what is AB plus CD. What is AB plus CD? Now AB, I can write it as AP plus BP. Now CD, I can write it as CR plus DR. CR plus DR. Now this will be, now AP is equal to what? AS. What is BP? AP equal to AS. BP equal to BQ. Now what is CR? CR is equal to CQ. DR will be DS. Now we know that what is it that we need to prove? We have to prove what is AD. For example, AD is AS plus DS. So AS plus DS, I will combine. So this is equal to AS plus DS plus BQ plus CQ. Now AS plus DS is what? This is AS plus DS is AD. What is BQ plus CQ? BQ plus CQ is BC. So we have AB plus CD is equal to AD plus BS, which is what we need to prove. So this is again an example of a problem where we have used the same theorem, that the tangents drawn from an external point to a circle are equal. You have to, sometimes the figure may not be given. So in that case, you must understand what is the meaning of a quadrilateral circumscribing a circle. Okay. So look at the figure. The circle is touching the sides of a quadrilateral at one point. Okay. So the sides of the quadrilateral will be touching the circle at PQRS. The points are PQRS. It is given in the problem itself. The figure is here. It is given. And we have made use of the result that AP equal to AS, BP equal to BQ, CR equal to CQ, DR equal to DS. We have simplified what is AB plus CD and we recognize it as AD plus BC. Okay. So are you able to understand? So today we have done 4 simple problems based on the same concept. It only depends on how you can manipulate and also use other features. In the previous sums we used Pythagoras theorem. For example, we also use radius is perpendicular to the tangent. We identified a square in one of the problem. So other features of geometrical concepts are also used to solve these problems. So please go through them carefully, and I am sure that you would have understood how to resolve such problems and also similar problems. So until we meet next time, it's goodbye. I hope you enjoyed the session, and if you did, do not forget to subscribe and share it with your friends. Goodbye.